Hello everybody, welcome into another lesson. So today we are going to talk about Descartes' rule of signs. So French mathematician René Descartes, way back in the medieval times, discovered about polynomials that you can ascertain the number of real solutions that a polynomial has by checking the number of sign changes a polynomial has. So again, this only works for real solutions. It doesn't tell you the whole story about your complex solutions, but it's a start. So to deal with what you got to do first, you have the original polynomial. In this case, we have f of x equals x to the third minus 8x squared minus 23x plus 30. We first, since this is the original polynomial, we're going to work on figuring out how many positive real zeros this potentially has. What you do is you check how many times it alternates from plus to minus. So x to the third is positive, but 8x squared is negative, so you have one sign change here. There's a sign change here, so that's one sign change. You have a negative on a negative, there's no change there, but from negative 23x to 30, you have another sign change. So we have two changes of sign from plus to minus, minus to plus, what have you, in the original function. So this tells you that there are either two, and if you have any number of sign changes, 2 or greater, it's going to be that number or 2 less than that. So you'll have 2 or 0 positive real zeros. So in the original function, first we're trying to figure out how many positive real zeros there are. There are two sign changes. So you're either going to have two positive real zeros, or since it's 2 or greater sign changes, you're going to decrease that quantity by 2. So you could have 2 or 0 positive real zeros. Now, what we have to do next to figure out the negative real zeros, you'll put in f of negative x for the function. So negative x to the third, that would give you negative x to the third. Then you still have minus 8x squared. This would give you plus 23x plus 30. So there's your f of negative x. We're now trying to figure out how many negative real zeros there could be. Well, there's only one sign change here between the negative 8x squared and 23x. So literally, you're just going to have one negative real zero. And since it's less than 2, you don't have to decrease the quantity by 2. So in the end, you have either 2 or 0 positive real zeros and then one negative real zero. And I got more examples of this here. All right, now, so how about f of x equals x to the third plus 2x squared, all right, minus 11x minus 12. So here's your original polynomial. F of x equals x to the third plus 2x squared minus 11x minus 12. Well, we're trying to figure out first, since it's the original, how many positive real zeros do we have? Notice there's only one sign change between the x squared and x to the first coefficients. You go from positive to negative. There's one. So you literally have one positive real zero. So you'll have one positive real zero. Now, we want to figure out the negative real zero. So put in f of negative x, put that in. Negative x to the third would give you just that, negative x to the third. You'll still have plus 2x squared. Then this would give you plus 11x minus 12. Now, how many sign changes do we have here? We go from a negative x to the third to positive 2x squared, so there's one sign change. We don't have any between 2x squared and 11x, but from 11x to negative 12, we have another sign change. So we have two sign changes for f of negative x. So there's going to be either 2 or 0 positive real zeros. I'm sorry, positive, negative, excuse me. 2 or 0 negative real zeros. So again, if you have 2 or more sign changes, just decrease the quantity by 2 for the other number you could potentially have. So there are 2 or 0 negative real zeros. All right. Alright, so we have f of x equals x to the third minus 7x squared plus 2x plus 40. So we want to first figure out how many positive real zeros we have. Well, between x to the third, negative 7x squared, there's one sign change. Then between negative 7x squared and positive 2x, there's another sign change. There's no change between 2x and 40, so you have two sign changes in the original, so there are either 2 or 0 positive real zeros. Alright, now we need to figure out negative real zeros. How many of those there could potentially be? So put in f of negative x. That would end up giving you negative x to the third minus 7x squared minus 2x plus 40. If you do f of negative x. And literally we see only one sign change. That's from negative 2x to 40. So you have one negative real zero. So you have either 2 or 0 positive real zeros or one negative real zero. If I could quit dropping crap. Alright, so f of x equals x to the fourth minus 3x to the third plus 6x squared minus 2x minus 12. Alright. So we have f of x equals x to the fourth minus 3x to the third plus 6x squared minus 2x minus 12. How many sign changes do we have in the original? Well, from x to the fourth to negative 3x to the third, we have one sign change. From negative 3x to the third to 6x squared, we have yet another sign change. And then from 6x squared to negative 2x, we have another sign change. We don't have one from negative 2x to 12, so we have 3 changes of sign in the original. So you're going to have either 3 or 1 positive real zero. because whenever you have two or more sign changes, you take the original and also decrease that by 2. So you'll have 3 or 1 positive real zeros. Alright, now we need to figure out negative real zeros. So let's do f of negative x. F of negative x would still, let's see, that would give you x to the 4th plus 3x to the 3rd plus 6x squared plus 2x minus 12. Alright, so let's figure out how many sign changes there are. There's only one, from 2x to negative 12. So literally you're going to have one negative real zero. So you're going to have either 3 or 1 positive real zeros, then you'll have 1 negative real zero for this polynomial here. Two more, then we're done. Let's see. F of x equals x to the 5th plus x to the 4th minus 9x to the 3rd minus 5x squared minus 36. Alright, so f of x is going to equal x to the 5th plus x to the 4th minus 9x to the 3rd minus 5x squared minus 36. So let's figure out the positive real zeros first. How many sign changes do we have? Our first one doesn't occur until x to the 4th minus 9x to the 3rd. As a matter of fact, that's the only sign change we have, so there is one positive real zero. We have just one positive real zero. Now the next thing to do is figure out how many potential negative real zeros there are. That's done by putting in f of negative x. So that would give you negative x to the 5th plus x to the 4th plus 9x to the 3rd minus 5x squared minus 36. Now, how many sign changes are there in f of negative x? Well, you have one from negative x to the 5th plus x to the 4th, so there's one. Then you have another from 9x to the 3rd minus 5x squared, and you don't have any others. So we have two sign changes. That means there are either 2 or 0 negative real zeros. So you have one positive real zero and then either 2 or 0 negative real zeros. Alright, one more, then we're done. Alright. X to the 5th minus x to the 4th minus 7x to the 3rd plus 11x squared minus 8x plus 12. So f of x equals x to the 5th minus x to the 4th minus 7x to the 3rd plus 11x squared minus 8x plus 12. Let's figure out how many positive real zeros there are. So, how many sign changes do we have? We got one from x to the 5th to negative x to the 4th, so there's one sign change. The next one doesn't occur until negative 7x to the third to 11x squared, so there's another. You have one from 11x squared to negative 8x, so there's yet another sign change. Then you have negative 8x to 12, there's another sign change. So you have 4 sign changes in the original, so that means that there are either 4 or 2 positive real zeros. So we for sure have positive real zeros. We just don't know if there are going to be 4 of them or 2 of them. But there are either 4 or 2 positive real zeros. Let's now work on figuring out the number of negative real zeros. So f of negative x, that's going to give you negative x to the 5th, still minus x to the 4th, plus 7x to the 3rd, plus 11x squared, plus 8x, plus 12. All right, let's see how many sign changes we have in f of negative x. Well, it would appear the only one is from negative x to the 4th to positive 7x to the 3rd, which tells you that there is one negative real zero. So you have one negative real zero. So Descartes' rule of signs is very useful to know the nature of your solutions in the real number system. It doesn't cover imaginary solutions, thus the whole set of complex. So the next lesson we're going to get into the rational zeros theorem, which will enable us to solve polynomial functions that are not factorable. It's useful if you can't factor them. So I hope everyone has a great day. Take care.